Hi, my name is Brendan Kinney. I work with the Maps API team, and I'm here to tell you as quickly as possible how you can make maps in your web browser work with the Crossfilter library for interesting data visualizations. So the Crossfilter library, if you go to their GitHub repo, is a great library for helping you explore, exactly as they say here, multivariate data sets. So data sets where each of your data points has multiple variables associated with it, and you kind of want to see how they interdepend and interrelate. So the example they have here has to do with airline flights and the amount of time early that they might arrive. And so you can see here kind of a classic view where you have multiple views into a data set. And we can look and see how the different histograms here compare. So we can see that the time of day is relatively evenly distributed throughout the day, but almost nothing at night. And you see how the distance and the arrival delay both have this long tail out towards the right. So what's great about kind of modern computer technology, browser technology, is we can drop this in and actually have these histograms be interactive. So I can look here and I can use this brush tool to kind of select subsets within one of these data sets and see how that affects the other views within the data. So you can see, for instance, as I come out here to the long tail, you get actually a large number of flights that arrive quite a bit earlier because they're so long, they have more time to arrive early, whereas much shorter flights tends to stick right around 0 and have that longer tail. And so actually each of these is interactive, and so I can select subsets within each and see how that affects the overall data. And so this is great because not only can you find new stories in here, because kind of relationships within data tends to not be even over the full distribution. So things that might be true between relationships between long flights and the arrival delay might not be the same relationships that, exactly as I said, short trips have with arrival delay. And so if you have just summary statistics where you see the full thing, you're not going to find those relationships. The other thing it allows you to do is allow kind of more lay people to come in and discover things about flights. I don't know much about distance and how that relates to arrival delay really, and so just by playing around with this, I can discover things and then kind of approach things more methodically after I kind of know what I'm trying to look for. So we want to look at how we can apply this to maps. So Crossfilter is really great for histograms and kind of graphs like this, but there's no reason why we have to limit ourselves to that. Crossfilter is really just a data library. It just spits out JavaScript values, and so it's up to us to create this interface. In fact, this interface is all D3. It's not the Crossfilter library at all. So I wanted to show you how you could hook that up quite quickly. So we're going to start off with an example data set. I just created this randomly, and I apologize for kind of the boring variables, but it's just a JavaScript array of JavaScript objects, and in each of these objects we have a latitude, a longitude, and two variables, a val1 and val2, that have different distributions that I've generated, and we kind of want to see how they relate to each other and then how they relate spatially. And so how we introduce that into Crossfilter is actually quite simple. The docs are a little daunting at first because Crossfilter is made to be very general, which is great later on as you start trying to expand the kind of visualization or cross-filtering that you do. The generalization, or being so general, is extremely helpful, but it can make it a little daunting to start at first. But here's a really simple way that you can start out, and it's just about as basic as you can get. So we create our filter by just calling the Crossfilter function with our point data, with that array of points. And then we actually create the dimensions that we want to explore on this data. So by default, Crossfilter doesn't create any dimensions. We have to manually make those, which is actually a good thing because that means we can pass any JavaScript objects in there, and they can contain functions. They can have pointers into the DOM, and we don't have to worry about Crossfilter kind of messing that up. It also allows us to create dimensions, variables that we're interested in that are actually derived from the data. So maybe we combine two data points into one kind of dimension that we want to explore. So that's all the kind of general stuff that you can figure out later. So for now, we're just going to make it really easy. We're going to say we're interested in a dimension of variables that's just the val1. And this is a function that's mapped over all the points and just returns from each point the val1. And so we create an array within Crossfilter of all the val1s. And then we make this kind of grouping, which is a little bit more abstract, but if you think of it just as kind of the histogram where we're bucketing them and looking at the frequency of each bucket, within the data set, it becomes a little more clear. So I know that val1 varies over 0 to 10, and so I just want to bucket it by integer. Since it's floating point, I just want to floor it and see it. Then I'm going to create another dimension for val2, and I again return val2, but val2 is much wider range, I think 0 to 1,000. And so I'm going to make larger buckets, and so I'm going to floor for every 25, I'm going to bucket it, but still keep it at the same value. So let's take a look at what that looks like. And if I refresh the page, you can see that we have two histograms here, value 1, which has this kind of almost a normal distribution maybe. So here's what this looks like. We have two histograms, and you can see kind of value 1 has this normal distribution, value 2 is a little bit more uniform. And I totally ripped out the histogram and brush code from the Crossfilter example and just adapted it to this data set, or not even adapted, I literally used it. And so now we can brush and see how that the two things relate to each other. So that's great. And you can see that this is already helpful. If these were meaningful variables to us, then it would be helpful. But we want to see, again, the spatial component. So what we do next is just add a map. And so you saw before that array of points each has a lat long value. So I can add a map, and then I can just, for each of those points, I can loop over that and add a marker to the map. And for each marker, I just set the lat long from that point. And now I have a point associated with each value. And so this isn't a view yet. It's really just showing where those points are. So I want to, kind of connect these two views to each other. So I need to bind first the map to to Crossfilter, and then bind Crossfilter to the map. So let's take a look how to do that. So what I want to do is bind the current view in the map to filtering to Crossfilter, so I can kind of filter the data based on what's currently in view. So to do this, I create two new dimensions, a latitude dimension and a longitude dimension, which are the simple dimensions that we had before, or similar to those, where they just return those values directly. And now what I can do is use a map event on bounds change to actually get the bounds, the most eastward, or most westward to most eastward, and most northward to most southward. And then I can use those to actually filter those dimensions. So I pass these things, and I say, this is pretty much just asking Crossfilter to filter out all the data points that don't fall within that range. So that's exactly what we want. We're now filtering on the bounds. And now when we refresh, we can see how that looks. And so you can see, as I move points in and off the screen, the histograms below change. And this is doing exactly what we were doing before. We were selecting subsets of the data by brushing within the histogram and seeing how that affected the other histogram. Now we're seeing, based on the points that are currently on screen, what is the distribution of the values that are associated with those points. And so you can imagine this is helpful as you zoom in. We can see, just like before, where we could see the long tail of distance was associated with certain patterns. We could see spatially, as we zoom into certain areas of the United States, maybe certain values have different patterns within that area. You can imagine, a different tool where you are actually dragging and selecting a bounding box, or any sort of thing like that. You're selecting, census blocks, and you could affect the histograms below. So now we need to go the other way, where the histograms, selecting with the histograms, drive what's on the screen. So we do that by adding one final dimension, and I just called it the ID dimension. And there might be an easier way to do this, but this is the first way I thought of doing it, and it works okay. So we'll use it for now. But if anybody has better ideas, feel free to leave them in the comments. There's probably a more idiomatic way. So in this, I just return an ID. So this is a little subtle, but this is a function that's mapped over our data, and with the built-in map array.map, the second thing that you get is the index within the array. And so I can just return the index of that point, so I know which point it was that created the current thing that's being filtered. And so I make a grouping of it where it's the full thing. So I have 300 data points, so this group is 300 buckets, and each bucket only has one thing in it or nothing in it if a point has been filtered out. And so when I created my markers, I put them in an array also that mirrors exactly the point array. And so what I can do is when I check a bucket with a particular ID, I can just go in and take that same ID, and set it either to visible or not if that bucket is empty or not. So that code is right down here, where I update markers. And so I get the grouping, and I do grouping.all, and this is something that this is kind of where I'm not totally sure this is the best way of doing it, but the nice thing about .all is that it's not creating a new array every time there's a change. It's actually using the same array over and over again. And so as I said, I just loop over those points, and I just check. I use the key, which is the ID, to look up into my markers array. And then I just check, if anything is in that bucket, I set that marker to visible, and if not, it's set to invisible. And so if I once more refresh the page, I come back here and you can see that it's still bound, so my view affects the cross filter, and now it goes the other way as well. When I filter the cross filter using the other histograms, I can see that it affects the markers currently drawn on screen. So if I only want the value 2s that are within this range, it will filter the histogram of value 1s associated with the same points, but it'll also affect the pointers that are drawn on screen. And so now we have a fully bound thing, and we can say, things only within this subset. It looks like this in value 2, and it looks like this spatially. And so once we have this, you can start doing all sorts of things. It gets a little hairy when you have a bunch of markers that are even more than this. So this is about 300 and actually works quite well. There's some performance things we can do with debouncing and that sort of thing, but actually the Maps API handles it fairly well, doing exactly that. And there's some really interesting things we could do with D3 and the Maps API, which both have kind of strong MVC or data-driven kind of views, and so there's more interesting things we could do with binding them together, and then we can take a look at things like WebGL, where we can display many more points, and we can express kind of these filter ranges in a more interesting way rather than looping over each point and then checking. We can do some interesting things with actually our geometry, but those are all talks for another day. So I hope this was helpful. Check out the source code, and feel free to make maps to your heart's content. We can definitely do more and more interesting things here, and there's no reason to limit ourselves to just a map or just a histogram when we have so much better things we could do.